Okay, welcome to this lesson on surface area. We're continuing from volume actually. So surface area, we are talking about surface area, right? We are talking about the exterior of the cuboid. So in my hands, I have a cube here. Okay, so you see this cube. Okay, we are talking about the surface area is all the exterior surfaces. Okay, so we are talking about all the exterior surfaces. Now, we're going to look at a cube and a cuboid first. Okay, we're going to look at cube and cuboid before we can go on to any other prisms that we have specified earlier. Now, one unique thing about a cube and to find the surface area is to open up the shape. Okay, when I say open up the shape, we are talking about the net of the solid. Okay, so what does it mean by opening up? So when you open up the cube, okay, so for example, this is my base. Okay, if I open up, okay, the other side, I will actually have 4 different squares, correct? I have 4 squares, and then I open up the other side, and I'll have 6 squares of equal length, of sides of equal length. So this is called the net. And from here, we can actually find the surface area, right? So I show you all one time. A cube like that, I open up, make it flat, open up, make it even more flatter. So this is actually the net of a cube. So I'm going to quickly just draw it over here. Okay, the net over cube. Okay, cube. It will be always good to draw this net whenever you are stuck with a problem. So the net of a cube. Okay, this is the base. This is this, followed by this, and this. Now, so in this case, my cube has length L, so I can quickly denote it as L here, L here, L here. Okay, and I can easily find the total surface area. So the total surface area, isn't it just the area of 6 squares here? Okay, each square has a side of L, so one area of the square is L squared. So total surface area here, in this case, is just simply 6 times the area of each side. Okay, 6 times the area of each side. Which is actually 6 times L squared. So 6L squared. Okay, the squared does not pertain to the 6, but only to the L, which is the length. Okay, can? So now we're moving on to cuboid. So give me a while. Now I have a cuboid in my hands now. Okay. So it's relatively almost similar. I'm gonna call this the length, breadth, and height. Okay. So when I want to look at the surface area, okay, there's a lot of things to take note of. Okay. Can you all see? Okay, from here, when I open it up into the net figure, it will be 4 different rectangles and 3 different rectangles. Okay, if you consider that the opposite sides will be equal, okay, so there are 3 different rectangles here. Okay, so I open it up once again. Okay, see carefully. Open and become something like it's almost similar to a cube, but the difference here is the dimensions here. So the length, breadth, and height, you need to be very careful here. Okay, another way to look at this is, okay, if I consider this side, this short side to be my base, right? Okay, and when I open it up, okay, if I open it up, right, these 4 rectangles form one big rectangle, right? Correct. These 4 rectangles form one big rectangle. Now, can I easily find the area of these 4 rectangles without computing each rectangle? I can. Can you see that the length of this larger rectangle here, so this length, this whole thing here, isn't it this length here? Isn't it just the perimeter of the base area? Right? I show again. So this is the base area, right? So the perimeter of the base area, isn't it just the length of this larger rectangle? Okay, this is just simply just the thing. So technically, the surface area of a cuboid can be easily simplified to 2 things. One is this long rectangle here, okay, this long rectangle, and these two base areas, okay, the base areas. Okay, I hope you all can understand this. So I'm going to show you all why this works. Okay, so let's go ahead. So of course it's good to always draw out. So if you draw it out, okay, carefully, okay, if you draw it out carefully, you should be able to come to the same shape as this lah. Okay, now be very careful to always note what you are drawing. So if this is B, this is L, this is B, H, and this is H. Okay, followed by this should be H, right? The height. Followed by this, followed by this. Okay, so it should look relatively similar. It's okay if you just sketch it on your paper. Okay, and the total surface area is just simply can you see that you can actually just add up everything here? B plus H plus B plus H, because this entire thing here is one rectangle as well, right? This entire thing here is one rectangle as well. Correct or not? This entire thing is one rectangle. And this B plus H plus B plus H, isn't it just the perimeter of this square? Correct? So I showed you all this just now. I'm showing you all this. So to put it in words, the total surface area, there are a few ways of computing this lah. Okay, is equals to the perimeter of base times the height, right? Okay, in this case it's length here lah. Okay, I'm going to use my base area change. I'm going to use times height. Okay, plus 2 times of the base area. Okay, I'm gonna have space, so give me a while. Okay, I'm gonna write it below. Okay, but technically it's the same lah. Okay, plus 2 times of the base area. Okay, actually this applies to all prisms. Okay, this applies to all prisms. In your textbook, you will see this. You will see that the formula comes differently. You will see that the surface area formula for cuboid is actually 2 times of length times height plus length times breadth plus breadth times height. Okay, so this is what you see in your textbook, which is not wrong. Okay, but in one of my work examples, I will show you how that I derive this. This is just simply just adding up all the 6 rectangles. Okay, can? So that is for the total surface area of a cube and the total surface area of a cuboid. Okay, now let's move on to cylinder. Okay, now I'm going to skip prisms first because I like to talk about cylinder first. Okay, now cylinder is relatively similar. It's not that different actually. So if I have a cylinder here, okay, I have this cylinder over here lah. Alright, then open this up first. Okay, as I should, if you see this cylinder, if I want to find the total surface area, it will be the outside thing that I can touch. Now we know that the base here is a circle. Okay, so opposite is the base, cross section is a circle. So we can simply find the area of the circle. Okay, we know that it's part of the total surface area. That's definitely the area of the circle lah. Okay, but with how am I going to find this? Okay, it's very similar to what we learned previously, that we are taking the perimeter of the base times height, right, to find the rounded side, right? If I open this up, okay, it's actually just a rectangle again. Right or not? See, every time I open it out, even though it's curved, right, but when I open it out, right, it becomes a rectangle. And how am I going to find the length of this rectangle? This length here, just now previously we said the length is the perimeter of the base. Right? So if my base now is a circle, but we don't really say the perimeter of the circle, right? We say the circumference of the circle. So the length here, okay, is the circumference of the circle, right? Circumference of the base times the height. Okay, so if I have this cylinder here, okay, I show you all one more time. One more time. So this is the cylinder, the 2 base circles, and when I open this up, it becomes a rectangle. Okay, quite simple, okay. Now, so if let's say, how am I going to apply it into words or whatsoever? So I will let the radius be r, and the height be h. Okay. Now the net of this figure. Okay, I'm going to write net of the figure. Okay, net of solid. I'm going to skip this first. I will come back to this later. But the net of this is just simply two circles. Okay, connected to a rectangle. Correct or not? It's just connected to a rectangle here, and then finally another circle at the bottom. Okay, isn't this very similar to what is here? Okay, so I open this up. Okay, and then it's quite similar, right? Just that I put the circles different location lah. But it doesn't matter. It's okay if you put the circle here, 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 here. As long as they are opposite each other, and we will combine them, it becomes a cylinder. Okay, so this is the net of the circle. Now, what is the total surface area then? Now, the total surface area is quite simple. This is just the area of the circle, right? So if my radius is r, so the area here will be pi r squared. Similarly for this will be pi r squared. So that's 2 times of the area of the circle, or the base circle. Okay, for this, okay, this is just h, correct or not? Okay, this is just the height h. Now the length, as I said, it is just simply the circumference of the base. The circumference of the base is 2 pi r. So your total surface area of a cylinder in this case, is just simply 2 pi r times h. This is just this one over here, plus in this case I got 2 area of the circle, so it's 2 times the area of the circle is 2 pi r squared. Okay, it's very important that you all get this correct. Okay, if you don't, this is just a formula, but you don't memorize the formula if you think about all this carefully. Okay, of course another simple way is just memorize formula, but what's the point? The idea here is to understand what a cylinder is made up of. How can I derive this length by actually simply using something you already know, which is the circumference of a circle. Okay, so now that covers cylinder, and cube and cuboid. Now let's move on to prism. Okay, of course there's a triangular prism here. I'm gonna redraw it actually. I'm gonna make the triangle the base. So let's say this is my triangular prism here. Okay, I have this is a right angle, and then this will be 3 cm, this will be 5 cm, this is 10, not 5, sorry, this should be 4 cm, and this is 5 cm, and the height here I let it be 10 cm. Now if I were to draw the back of it, with dotted lines, so it should look quite similar to it should look quite similar lah. So just like that. Now, just now we said that, just like a cylinder, just now we said that a cylinder, this length here, is just the circumference of the base circle. Similarly to a cuboid, if I regard this side as my base, so it will be like that, right? To find this thing, it will be the perimeter of my base area. Okay, so what if I have a different kind of prism? For example, the triangular prism just like that. I'm going to pluck it out first. I'm going to show you all the net figure. This is the triangular prism. So with this triangular prism, what I'm going to do is this is my base area. I let my triangle be my base area. So can you see these two are my base area? Now, how am I going to find these 4 sides? Of course, it's just 3 rectangles. You can say, I just find 3 rectangles. But that is definitely possible. But as I said, is this efficient? Another way to look at this is similarly to the cuboid and the cylinder, this whole thing is just another rectangle. And you see that this is just another rectangle. And this rectangle, this length here, is just the perimeter of the base area here. So can you all see that the perimeter here is just, the perimeter of this triangle is just the length of this huge rectangle. Okay, this is just the height. So in this case, my net here, okay, I think I'm going to just quickly draw the net here. In this case, let's see, I don't think I'll draw the net for this. I mean, you could definitely draw the net for this. Okay, it's very simple. It's just 3 rectangles with 2 triangles. I don't think I'll go to that stage. But I will talk about the idea of finding the surface area of any given prisms. Okay, I don't necessarily need to have a triangle here. I can have a parallelogram. I can have a weird shape as long as I know the perimeter of the base area. Okay, so let's quickly do this. So same thing, the total surface area here for any prism. Okay, in this case, I will just say the triangular prism lah. Okay, in this case, it is just the okay, we're gonna use this thing again. We're gonna use this thing here again. Okay, perimeter of base times height. Okay, plus 2 times the base area. Okay, so for this triangle, the perimeter of the base area is just adding up the sides of the triangle lah. So that is 5 plus 4 plus 3, right? Okay, and this is the perimeter of the base area. I'm going to multiply it by the height, which is 10. Okay, this is to find this thing. Okay, the surface the area of this rectangle over here. Okay, so this is just to find the surface area of the rectangle over here. Now I'm going to add 2 times of the area of the triangle, because this is considered the base area, right? So we simply know that this is just half times 3 times 4. It's just simply half times 3 times 4. Okay, and you can just add them out. So in this case, it will be 120 plus 6, and you have 126 cm. Sorry, I do wrongly. It shouldn't be 6, it should be 12. Okay, 12 and 132 cm squared. Okay, can? So the idea from this lesson, okay, in summary, is just that to find the total surface area of any prism given a cuboid, cylinder, or even a tube actually, or anything. So I can have a random shape here. Let's draw a random thing lah. Okay, I can have like a weird shape. Oh no, that's too weird. Okay, let's make it simple a bit. Okay, let's say I have something like that lah. It's weird lah. Okay, I know. Yeah, but let's say I got this prism over here. Okay, I can find the total surface area if I already know the area of the base area, and I also know the perimeter of the area. Perimeter of the base. As long as I know these two, right, I can find the total surface area of this, because simply, okay, as I reiterate, for any prism, the total surface area is just simply perimeter of base times the perpendicular height. Okay, as we mentioned before, height always refers to perpendicular height, plus 2 times the base area. Maybe I should use a different color such that it's a little bit clearer. Okay, so this is to find the surface area of any prism given to you. Okay, so this please look at the work examples that I've given. I have a special part to go through with you how to find how do I derive the total surface area of a cuboid as well. Okay, so that will be all.